Duckman here today. Got a special edition on today. So I got an interview with Nina Walters down at Uni of Western Sydney for people that aren't sure, down the PN. So Nina works in the project as a team manager for a solar power car challenge. Can you tell us a little bit about that, Nina? Thanks for joining us today. Appreciate your time.
Yeah, thank you for having me. So we're the Western Sydney Solar team. So what we do is we design, engineer and build solar-powered race cars that then we race from Darwin to Adelaide in the Bridgestone Workd Solar Challenge, which is just over 3,000 kilometres. And we're an entirely student-led and run project. So it's all students at the university that are doing this.
That is very amazing, and I appreciate the little walk around and tour you gave me before. Get excited seeing these sorts of things. It's way out of my scope of being able to do anything even half as cool as this. So, chatting to people that on the ground do it and are passionate about it, it's really good to see. Particularly working with like new technology and renewable technology like solar as well.
Yeah, it's really cool. I think one of the coolest things that we get to do is test out all of those new technologies. So it's different every time. We'll try different battery technology, different solar cell technology, and we pretty much aim to push the boundaries as much as we can to see what we can actually achieve.
So now you told me the solar challenge goes so. Uni Western Sydney started getting involved in it back in 2012, and the challenge goes from Adelaide to Darwin. Can you tell us a little bit about that, please?
Yeah, so the team did first get involved back in 2012 and competed for the first time in 2013. And we've competed a couple of times since then. So we competed in 2015, 2017, 2019, and 2023 as well. We've had some pretty good successes. We also competed in the American Solar Challenge in 2018 and we got first place there, which was quite exciting. But yeah, so it's a race from Darwin to Adelaide. So it's just over 3,000 kilometres and there's about 40 teams from all across the world that will compete. Within that, there's two different classes within the challenge. So there's the cruiser class and the challenger class. We compete in challenger class, which the goal of that is essentially make the most efficient car you can and get to the end as fast as you can.
Yeah. So I've seen all technology you got inside. So a lot of that looks like it's made in-house or bought. You said you got brakes and that stuff from go-karts. So you get bits and pieces of things you can use wherever you can, but got carbon fibre bodies made in-house, I imagine, and most of the components and the electric parts, because it's an electric engine, they're all made in-house by the students in the uni.
Yeah, so we always aim to do as much in-house as we possibly can, just because one of the big reasons why this project exists is so that students can get that kind of experience. Yep. So with our 2023 car, we were able to do a lot of the composite work in-house. So the only thing that we had done externally was the actual aero body itself, because it's quite big. But the entire chassis and all of the structural panels and everything like that, we did ourselves in-house. In terms of suspension, there are some parts we do buy, such as the brakes, and there's a lot that we also get machined externally, but it's all students' designs that get used for that. And then a lot of the electricals as well, students making those boards and putting together all the battery cells and that sort of thing.
So it must be really cool to be involved in a project like this. So what year are you into uni? You're 20 now, so how long you been at the uni for now?
Yeah, so I'm in my third year studying engineering, and it's my third year on the team. So I joined the team at the very, very start of my degree before I'd done a single engineering class because I saw the car at Welcome Week and I was just thought that it looked like the coolest thing I could possibly find to get involved with. So I decided to join.
Yeah, so that's good. So you'd be a veteran of the team. Some of the guys inside, they've got some ranging ages by the looks of that, mid-20s, some guys in there, and perhaps some younger guys and some older people involved too in the process. And then it look like you've got professors and that like to stay in touch and want to see how it's all progressing.
Yeah, so it's a lot goes into the project, and one of the cool things is that we're not really limited in terms of who we can accept into the team for the project. So we're not even limited to engineering degrees. So at the moment we've even got a medical science student, we've had business students and IT and computer science, as well as a lot of engineering students naturally. But yeah, we do get a lot of support from other people in the university as well. So some of the academics really love to get involved, and just the general support from the university is usually quite good.
Yeah. So it is massive. So I found out about this through Christian Burden, who is working down at UWS at Parramatta, I believe. I think it's called Parramatta, is it, or Westmead? So, but it was great when we found out about this and that the car ran from Adelaide to Darwin. I was questioned or interrogated, I'll say, Christian about this a fair bit, and he said, I'll put you in touch with the people once they get back from holidays and they can have a chat. So I was very happy that this has all come about, and it's exciting to me because as a kid you see all these things and think, oh, I can do that, I can do this, and when you look at it, you probably can't, but it's it's very exciting to be involved in the project.
Yeah, definitely. I mean, just the amount of support we get is definitely crazy. But I would say probably anybody really could do this. I mean, most of us do join very early in our degrees with not much experience, but one of the good things is that whenever you join, there's always people that do know things, and it's kind of just a cycle of teaching the next person. Yeah. And yeah, I would say from my personal experience studying engineering while being on the team, I think I've learned significantly more by doing both at the same time. I mean, you'll have times where you've learnt something in class and then you're doing work on the team and you realise that you're using the theory that you learnt in an actual, like,
You can see
yeah,
the reality of it.
yeah, it's actually, and you have almost a light bulb moment where you realise why you're learning the things you are learning in your classes, and just getting that kind of real world experience is, it can make such a difference.
Yeah. So this is mechatronics we're talking about too. So like back in the day, because I'm a little bit older than you, I'm in my mid 40s. Mates are mechanical engineers and stuff. They would love seeing this now. So, but what we consider mechanical engineering and combustion engines, that sort of stuff, that's all changed and it's different now. Can you give people a bit of a rundown and explain some of the differences between like mechatronics and mechanical engineering?
Yeah, so mechatronics is the easiest way I've found to explain it is it's a cross between mechanical and electrical engineering. Yeah. So half of the units you do during your degree will be mechanical units, so that's all the physics relating things, materials, all of that sort of thing. And then you'll have the other half of your units will be electrical, so that can be to do with circuits or to do with, we even do programming subjects and that sort of thing. So it kind of leads you to have a whole lot of different options in terms of what you can do with your degree. So you could go into a more mechanical role, you could go into a more electrical role, you can get involved with robots or even electric vehicles.
So that sounds exciting all on its own. So when you perform in the race as well, so how many people you take away in the team with you to compete at the event like you just recently did?
So we always aim to take as many people as we can, and last year we were lucky enough to be able to take everyone. So we usually have a team of between 25 and 30 students, and we were able to take about 30 students with us last race. You really do need as many people as you can though, because you're testing the car while you're there. We spend 2 weeks in Darwin prior to starting the race, where you're based there with all the other teams testing and qualifying and all of that sort of thing. So you need all of your mechanical and electrical teams to keep the car running. You need your strategy team to be working out their strategy plan for the race. You need your media and your partnerships, and you need everybody there to keep everything running.
So to get everything, so have you watched the car race movies back in the day, the Days of Thunder and all these sorts of things? Is there a bit of Robbins racing and that on the road too, like get teams near each other and or get a bit close and bump the bodies and that stuff, or it's not really like that? Try to work more on the strategy and everything behind it.
Yeah, it's definitely more on the strategy. Like, you definitely see a lot of competition between teams, a lot of friendly banter and that sort of thing as well. But there's actually a lot of rules in terms of, how close you can get to other teams and how you have to overtake them and all of that sort of thing. But everyone has radios as well. So each team has a different UHF number, and so you can tune into their radio to talk to them if you need to tell them anything or ask to overtake. So it's very friendly, but you'll still get the friendly banter at the same time.
So it's not like Bathurst then. You said you grew up out at Blaney and not rubbing people into walls and off the road into the bush and like, well, best of luck, I'm going to take your position now.
Yeah, definitely not. I think we all kind of have a pretty good mutual respect almost for everyone, because we've all experienced the same thing, and really everybody that is involved in any of the teams across the world just love the project. And once you get to the point of actually being there to race, it's a 2-year cycle, so you've spent 2 years putting all of your time and effort into designing and building this car. So once you're actually there to race, everyone's kind of on the same level of understanding of, you know, you want everyone to race. So even in the past when there's been other teams that have had something go wrong, there's always other teams have helped them out. That happens quite often.
Approach.
Yeah.
That's a good approach. That's a good approach to have. So you're the team manager as well. So what does that role entail? Sounds like you do all this sort of stuff, get some positive media. You work behind the scenes to work with suppliers and all the bits and pieces. You crack the whip a bit and to try to make sure you get things done so people are not being a bit tardy with time and all that sort of stuff as well.
Yeah, definitely. So there's a lot of that. It's a lot of, you know, keeping everyone on track. We do have to be pretty strict with deadlines and that sort of thing. But it also involves things like just, you know, making sure we're following all the right university procedures and that sort of thing. A lot of the logistics and admin work, sometimes that does involve dealing with the partnerships and making connections with those sorts of people. It can involve doing media things like this. Also dealing with all the finances and the purchasing and that sort of thing.
So you get to do procurement and everything. Are you going to get like some minors in procurement and that after this and take that away to finance and bits and pieces? So make sure you throw all that on your resume. It's going to come in handy one day.
Yeah, definitely. I think it's been a great experience. So I was a project support officer before I took over as team manager, and just that kind of experience that you gain from doing all of this side of the project as well. So I was mechanical for a long time on the team before I became project support officer. So I got good engineering experience, and now I'm getting kind of the leadership and admin and logistics experience as well.
Yeah. So you've got the whole mechatronics part, mechanical and electrical engineering coming together is one, I would imagine just from my experience seeing things happen in the world, changes that there's a lot more reliance on electrical and stuff like that compared to the old style combustion engines and for what we would consider classical mechanical drive lines. That car's a good indication inside. So it's got independent suspension, independent drive shafts effectively at every wheel. So it doesn't rely on axles, doesn't rely on a tail shaft, doesn't rely on differentials and cam shafts to drive it. It's all electrical and solar power. So do you think that will keep changing and evolving over the next 5 years, 10 years, 20 years, even in like commercial cars and stuff like that?
Yeah, I think we're definitely heading in that direction, and I think probably a lot faster than what most people are expecting. It will still be a decent amount of time before we will start seeing solar-powered cars and that sort of thing that are actually practical to drive, because part of the reason why we're able to travel such a long distance is because of how small the car is, how light the car is, and all of that sort of thing. So you can't really transfer that into a practical everyday car. But a lot of the technology that we're testing is then able to be used in those sorts of scenarios where it can be practical. So I guess essentially we push the technology as far as we possibly can so that then we know what the limit is, and then that can be taken back and then reduced almost and put into a more practical situation.
Yeah. So that's what I wondered, right? So did you have solar cell storage panels or something like that where you could store solar energy or power and reuse that at another time, like you would have with lithium? You can recharge lithium batteries to a certain level and that sort of stuff and bring it back to some charge, and they normally charge by getting used because they've got drive shaft pumps or power back through it. Does the same thing happen with solar, or could it happen with solar in the future where you can store cells of power and reuse that?
Yeah, so that's, I guess, similar to what we do with the car. So we do run a battery at the same time, and we can choose to use that power or just use as much power as what we're getting in from the solar cells. And obviously, if it was the sunniest day you've ever seen in your life, we'd probably be able to get power in and store some of it and then use some of it, but be gaining power at the same time. I think that's definitely becoming more and more possible. Again, a big thing with that is it comes down to how the car is designed. Yep. So for our cars, that's definitely possible. But in terms of the more practical everyday cars, it's not as easy because you'd be using a lot more power than what one of our cars typically uses. Yep. But definitely being able to store power is very, very possible. Yep. And there's a lot of different solar technology and battery technologies that are kind of coming about at the moment. And with that, you're able to store more power with less battery weight. You're able to get more power in with less cell area. So all of that kind of thing, as that progresses, that's going to be what makes the big difference.
Yeah. So I've seen that. You can see that with mobile phones too. The storage, what used to have mobile phones and computers, the size of them, vast physical size is much smaller now. It got more power to be able to do everything and carry out more applications. A basic phone back in the day could text and you could ring people. Now they've got the ability to do all this extra stuff. It does drain extra power and that, but the size of batteries and the lifespan of these things is amazing compared to what once upon a time would have been nearly like as big as the bin to do different stuff. So it is interesting. You also said Bridgestone, they are one of the major contributors here and sponsored a whole challenge. So what do Bridgestone actually do and how do they help all the teams out?
Yeah, so Bridgestone do sponsor the challenge itself, so it's the Bridgestone World Solar Challenge. They use the challenge and the cars as a way of testing their technology. So for the tyre compounds, when they're creating a new one, they then provide all of the teams with those tyres. We take them and drive them for 3,000 kilometres. We take in all the data, so things like how far each tyre has travelled, where it was on the car, if we rotated them or anything like that. Any failures, so if we do have a blowout or a puncture or anything like that, and we report all of that back to Bridgestone, we give them the tyres back and they take all of that information away from all the teams and use that to make sure that the tyre compound is at what it should be. They'll use it to change things, improve things, and then they will actually release it to regular cars.
So when you show me the carbon fibre body, when you just visually look at it, it looks like, oh, potentially that'll be heavy, but a surfboard potentially looks like it could be heavy too, till you look at it and touch it and realise it's not. Now, it's got like honeycomb setup, so for anyone to imagine inside, it would be like looking into the inside of a cardboard box, how it's set up. So, and all the strength in the frames, as you said, the downward pressure is okay on it. The solids pressure is going to affect it and potentially crumble. It's the weakest part of the setup of the body. So I imagine it hits and knocks anything bad, like a crash off the road could be catastrophic for the whole setup of the car.
Yeah, so we design them to be quite strong. So we use kind of a combination of different things. So the whole car is made out of composites. Your actual aero body, which is that outside shell, it tends to be fairly weak. You just want that part to be light. It's really just there to get you the aerodynamics and the efficiency that you want. But then within that you have the actual chassis. That is always incredibly strong. That's what protects your driver. So that a lot goes into making sure that is very, very safe. And then you have all of your structural panels that essentially hold your chassis and aero body together to make it one whole car. We use a couple of things. So there's obviously carbon fiber is the main thing that we use. But then we also use Nomex honeycomb, which is that material that looks like the inside of a cardboard box. Yeah. And that's incredibly strong, but also very light. And then we also use foam core, which is a very, very dense foam. That's the same thing, so it's quite strong, especially when you put it between the carbon fiber. This Nomex honeycomb is the same, but still very light.
That's so like bonding and effectively like a glue-like substance and that sort of stuff.
So it's essentially these sheets of foam. Yeah. Almost if you imagine like a foam mattress, but like a very dense foam rather than the squishy foam. And then it's basically a sandwich technique. And so we do the engineering, you work out where you need how many layers of what. So sometimes you'll have 2 layers of carbon, a sheet of foam core, another 2 layers of carbon.
Yeah. So will a sheet of foam core, will it be like an actual sheet, or is it like a liquid you need to spray in and set and then lay the next layer over the top of it?
No, so it's an actual sheet. Yeah. So we'll cut it to shape and then put that in. We use glue film in between to adhere it to the carbon, and then all of our carbon is cured under vacuum and baked in the oven essentially. Yeah.
So did you ever think in your life when you were sitting at high school or anything like that, so growing up out in Blaney up North Coast when you moved there, did you ever think, I'm going to go to uni and I'm going to become part of a solar power challenge team and I'm going to do some cool stuff. I'm going to travel around the world a little bit doing this and be involved in some really interesting projects and stuff like that. Did you ever envisage that would be something that you would do?
I never even thought of it. I didn't, to be honest, I had no idea that solar racing was even a thing until I saw this team for the first time. So towards the end of high school, I saw an FSAE team at another university, at Newcastle actually, and I got to see their cars, their workshop, and kind of at that point I was almost finished school, looking at university, and I thought I really want to get involved with a project like that. So that was kind of where it started. And then when I saw the solar car at the open day when I was starting uni, that was the first I ever knew of solar racing, but I haven't gone back since.
Yeah. So, what sparked your interest to get into the whole mechanical engineering part at school? What was the trigger, and when did you think this is the pathway I'm going to go? Because I wouldn't say it's not a traditional pathway, but it's not. I wouldn't think there's many people that look at that right now as perhaps what might have been considered traditional in the 1950s, 60s, 70s, and all that sort of stuff.
Yeah, I kind of came to the realization that it was what I wanted to do pretty late in high school. So I was one of those kids that thought I had like my whole life planned out, right? I was pretty convinced I knew exactly what I wanted to do. And so I would have been about 10 when I decided that I was going to do science. Yeah. I wanted to do astrophysics, and that was my whole goal. I think by like year 8, I decided what university I was going to. But then towards the midway through year 12, I just bought my first car, and I was fixing it with my dad because I just bought a pretty rundown car and he was teaching me how to fix everything. Yeah. And I also was doing physics as one of my subjects, and we had to build a motor for an assignment, and I had the time of my life building this silly little motor. It was just a couple of wires and a battery with a little switch. But then kind of after that point, I realized that was definitely more what I wanted to do. Yeah, like I like the research side of science, but I also wanted the problem solving side of engineering. So that was kind of what triggered the decision.
Being able to do and test yourself, and not just see behind the theory of it, but put it into practice. And
yeah, exactly. Yeah.
So, wow, that's pretty cool to be involved like that. So I imagine there'll be a lot of people with similar stories like that in the university here. So I never went to university, but tried a couple of different things out. And as I've got older, I realised logistics fits well and all that sort of stuff. And there's bits and pieces for that as well. But I imagine there's people inside that come from some very dynamic backgrounds and everything like that are involved in the team too.
Yeah, definitely. We've had all different kinds of people come on the team, and I think that's what makes the team successful as well, because realistically, if you have a team of about 25 engineering students that have always wanted to do engineering and can only think in that engineering mindset, you're not going to get very far. You need all different kinds of thought processes and mindsets. So we've had people that have come from being tradies, like a mechanic or an electrician, that have just started their degree after being a tradie for a couple of years. We've had people that have come through the college at the university as well. We've had people that have come that aren't even part of the university. So we've had some people that were studying at TAFE that have joined the team. And again, like I said before, all kinds of degrees. So you kind of really get to see a very wide range of people come through the team, which is really cool.
Yeah. So you've got different mentors and people that like sort of oversee the team here and help give guidance and coach that. Maybe not be hands-on in that all the time, but be able to be there to be someone to lean on and all that.
Yeah, definitely. So we've got the steering committee, which that's kind of all of the people from the different areas of the university that we deal with, and so they make sure we're heading in the right direction. And then we've also got an academic committee, and so within that we have academics from each different kind of discipline of engineering, and so they're able to help us out a lot with more of the technical things. And we do have an academic advisor for the team as well, who kind of oversees the whole thing, and they're always really helpful. We always go to them if we have run into troubles or anything like that. So
yeah. So I know that Bernard directly put me in touch with you, so it was great. How is he involved with the team? And it must be great having someone as passionate as him involved in projects like this as well.
Yeah, so Bernie is amazing for the team. So he's been on the team for a fair few years now, and he actually joined because he wanted to get back into engineering. So he joined to do engineering on the team, and that slowly evolved into more of an advisory position, as well as doing a lot of partnerships for the team. But having Bernie on the team definitely gets us a long way. He always knows what to do in any situation. He has a million connections with all kinds of people, and he always has the right outlook on things as well. So it's really great to have Bernie on the team.
So one thing I like, everyone I met so far seem to have like really positive outlook on everything as well. So you haven't got anyone in there that looks like they're throwing any tantrums and throwing things around, or I've got no doubt you're going to come across problems in there to encounter. There'll be harsh times in there when it'll be difficult, but having a positive outlook and everything like that, and positive people around must be make it a good experience to be involved with as well, and then help get positive results for the competition and people's like academic understanding and stuff too.
Yeah, the team is a pretty good team. It's really like a family almost. I mean, you're spending hours and hours each week with each other. And I think what makes it so good is that you're all here because you all really love this one project and the same goal that you're working towards. So there's still naturally, there'll be disagreements with things, but at the end, everybody's working towards the same goal. So we never really have any huge issues or anything like that. And everyone is pretty logical, pretty forward thinking. So if you kind of present your idea with your reasons why and the other person does, then you can see which decision is the right way to go, and everyone's usually in agreement with that.
Yeah. I think that's a good approach to have, really. So you need to have an open ear, good listening skills to be able to work together well in a team. Otherwise, you're going to have a dictatorship that won't work so well. So how good does it feel knowing, where did Australia come in the last competition last year from Adelaide Darwin? Did we win it?
We didn't quite win, so we placed 9th overall. We were, out of the Australian teams, we were placed first, so we were the only Australian team that even completed the entire race.
Really?
Yeah, so that was a pretty big achievement for our team. The team that actually won was a team called Inoptis, and they're the Belgian team. Usually the European teams are our big competition, but we've managed to always place top 10 with the rest of them, so...
So that must be good. When you won the competition in America and won that, was there large? I imagine there was very large celebrations that went on afterwards and stuff like that.
Yeah, so that was a crazy achievement for us. So we were the first international team to actually win that competition.
Oh,
Previously,
really?
the American teams had been the only ones that had won it. And Michigan had actually had something ridiculous like an 18-year winning streak that we took from them. So
effectively done an America's Cup style win.
Yeah, pretty much.
So how did the American universities take that? Did they take that in good jest, or was that like, they felt like they're taking their birthrights off them or something like that?
It was all friendly, but naturally they were not the happiest with it. But there's a competition, so.
So what's the goal for 2024 with it? You're building the car again now, going through the testing phase and everything like that. When will the competition be up and running, and when we'll be able to find some more information out about what's happening with the project and later on the competition too?
Yeah, so we get the new rules for the competition hopefully towards the end of this month. And then from there we'll start designing the new car. It's about an 18-month process, so we'll start designing by the end of this month. We'll start manufacturing towards the end of this year, ready with the car built to start testing mid next year, so that we can test for a few months before we leave to compete in October next year. So it's a pretty long process. Between now and then we'll also go on a regional New South Wales roadshow, which is pretty much where we'll take one of the previous cars around New South Wales to regional areas to try and get some exposure there and do some outreach in the areas that probably don't see projects like this. So.
Yeah, that's a pretty good way to approach that too. So next year will be your 4th year in uni. You are going to kick on to do a degree with honours, and then go on to your 5th year, obviously.
Yeah, so that's probably the goal. That's what I'm looking at the moment.
So is this going to be one of your major works? You're going to try to submit, I was involved in this little project, so here's some of the running data on it. That might be pretty good to add in towards your thesis and the back end of your major.
Yeah, I think it's definitely a possibility. I mean, if it's something that you have experience in and that you're pretty familiar with and understand, it's a pretty good option for that kind of thing.
So in regards to driving, how do you work out who's going to drive the car, and a lot of people who are going to take turns for that, or people like start to get themselves into shape and condition, thinking they're going to be driving it and be prepared for it?
So we're allowed to have 6 drivers. So we had 3 primary drivers and 3 backup drivers. And the way we choose the driver is a couple of ways. So you have to be a minimum of 80 kilos. And if you're not, then you have to have ballast with you. So we try and get people that are as close to 80 kilos as possible. We had a few people that were just under, a few people that were just over. And everyone was pretty much working towards that 80 kilo mark. Yeah. But then we also do a whole lot of driver training and driver testing, where our strategy team will actually essentially judge the drivers based on how efficiently they can drive, because that's, at the end of the day, we need the driver that can drive the most efficiently. Yeah. And obviously it's also important that they can safely drive the car as well, so we don't usually tend to pick any of those crazy drivers. But yeah.
So how many women are driving in the team?
So I don't think we've ever had a female driver before, to be totally honest.
Yeah. Is that something that you'd like to see before the end of your time at uni? You'd like to see hopefully get a female driver? Have you got interest to have female drivers in the team?
Yeah, 100%. So when I first joined, I wanted to be a driver, but then things didn't quite end up working out that way. I kind of got preoccupied doing other roles in the team and that sort of thing, and I'm a fair way from the 80 kilo mark, so it wasn't all that practical.
80 kilos, you need to put some weight on.
Yeah.
So, might go and pay some visits to KFC and anything like that.
Yeah, definitely. But we do have quite a few girls on the team now. It's the most that we've ever had, and I know there are a few that would definitely be interested in driving, so I think it's definitely possible, and I would love to see it happen for sure.
So there you go. Thank you very much for your time today, Nina. Really appreciate it. This excellent little project that going on out in the western suburbs of Sydney. People wouldn't know about otherwise. So that's why I was happy to get involved in this and bring some exposure to the team and hopefully get some more interest in maybe corporate sponsorship and stuff like that. How could you get involved if you're a corporate person and you want to get involved with this project?
Yeah, so definitely just reach out to us. Even if you're not a corporate sponsorship, even if you're just interested in the team. So we're on pretty much every social media. We also have our website. If you just search Western Sydney Solar Team, you'll find our website. On there's a couple of different ways to contact us. You can submit a little form that will come through to us. Our contact email is also on there. If you just reach out to us in whichever way is easiest, we're always happy to get involved with people, whether it's industry or schools or just anybody that's interested.
There you go. Right. Thanks very much for your time, Nina. Really appreciate it. So there you go. How is that for a little project out here in the western suburbs of Sydney? So would never have known about it other than hitting up people that I know and following up interesting new challenges. I always look for different stuff that's out there, and this is something I seriously didn't know about. I want to come across it. I just knew straight away, wanted to get involved and see what I could do to help promote it and find more out about it. So Nina, thanks for your time, and I've got no doubt I'll chat to you again sometime soon.
Yeah, thank you so much for talking to me about this. It was great to share everything with you.
I'm very glad. I'm very glad I got to see it too. So, and in the implementation stage too. So, everyone will be able to catch this later. So, we'll be a story in the Hills Independent magazine. It's also going to go up on Duck Media and Duckman TV on YouTube. So, you'll catch all of that. And I will share a copy with Uni Western Sydney so they can share through their social media too. Keep on ducking, everyone. Have a fantastic day. And I'll catch you again soon.